Hello students, welcome to our channel Learning Notebook. In today's video, we will do complete chapter of Geometrical Constructions for class 7. So let's see what all topics we are going to cover in this video. We will learn about angle bisector, perpendicular bisector of a line and its construction, property of angle bisectors of a triangle, property of perpendicular bisectors of the sides of a triangle. Then we will learn about construction of triangles and we will also understand congruence of segments, angles and circles. In previous class, we have learnt about line, line segment, angle and angle bisector. Now students, let's revise angle bisector once more. Angle bisector is a ray from vertex of angle such that it divides the angle into two equal parts. See the diagram here. Here we have an angle AOB and ray OM divides this angle into two equal parts. So OM is an angle bisector which divides this angle into two equal parts, angle AOM and angle MOB. Now students, let's understand perpendicular bisector of a line segment. Perpendicular bisector is a line perpendicular to and cuts the line segment into two equal parts. Like here, AB is a line segment and CD is a line perpendicular to AB which cuts AB into two equal parts, AM and MB. So, CD is a perpendicular bisector of line segment AB. Now students, let's understand how to construct a perpendicular bisector. Question is, draw a line segment PS of length 8 cm and draw its perpendicular bisector. Name it line CD. In step 1, let's draw a line segment PS equals to 8 cm with the help of a ruler. Now, in step 2, with P as center and radius more than half of PS, draw arcs on each side of PS as shown here. If you are enjoying watching videos on our channel, then do like, share and comment on our videos. Also, do not forget to subscribe to our channel Learning Notebook. In next step, with the same radius and S as center, intersect the previous arcs on each side of PS and then name intersecting points as C and D. Now, in last step, we will join CD which will intersect line segment PS at point M. Line CD is now our required perpendicular bisector of line segment PS. Let's verify it once. For this, take the help of a protractor and measure the angle CMS, which is equals to 90 degree. Now, with the help of a ruler, measure the length of PM and MS, which we can see as 4 cm. So students, it means line CD is the required perpendicular bisector of PS. Students, If you are looking for maths projects on how to draw mandala art or Varli art using geometrical figures, then don't miss to watch our videos. The link to these creative videos are below in the description box. Now let's learn about the property of the angle bisectors of a triangle. To understand this property, let's draw any triangle PQR. Then, with the help of a compass, draw the bisectors of all the three of its angles as shown here. These three bisectors pass through the same point. That means they are congruent. Let's name the point of congruence as I. Now students, note here that the point of congruence of the angle bisectors of a triangle is always in the interior of the triangle. Now let's draw perpendiculars IA, IB and IC respectively from I onto the sides of the triangle PQ, QR and PR. Then we will measure the lengths of these perpendiculars and then we find that IA equals to IB which is equals to IC. So students, the point of congruence of these angle bisectors of a triangle is called the incenter of the triangle. Here, I is the incenter of this triangle PQR. So, if you draw a circle taking I as center and IA or IB or IC as radius, the circle will be drawn as shown here. This circle will be called as incircle of triangle PQR. Now students, let's learn about property of perpendicular bisectors of the sides of a triangle. To understand this property, let's draw an acute angle triangle XYZ. And then we will draw the perpendicular bisectors of each of its sides. Here you will notice that the perpendicular bisectors of the sides are congruent. Let's name their point of congruence as C. Now let's measure the distance between C and the vertices of the triangle with the help of a ruler. You will find that CX equals to CY equals to CZ. So students, observe that in case of acute triangle, we are getting the congruence point inside the triangle. Now, let's draw an obtuse angle triangle XYZ. Then, draw the perpendicular bisectors of each side. Here, you will notice that the perpendicular bisectors of the sides are congruent and let's name their point of congruence as C. We will measure the distance between C and the vertices of the triangle using a ruler. You will notice that CX equals to CY equals to CZ. Now, here observe that in case of obtuse triangle, we are getting the congruence point outside the triangle. So students, the perpendicular bisectors of the sides of a triangle are congruent in both these triangles. and their point of concurrence is called the circumcenter and is shown by the letter C. Now, if you draw circles taking C as center and CY, CX or CZ as radius, the circles will be drawn as shown here. These circles will be called as circumcircles of the triangles. Students, if you want to learn type of numbers and how to make a working model on it, then do watch our separate video. The link to this video is below in the description box. Now, let's start with construction of triangles. First, we will learn how to construct a triangle when the lengths of its three sides are given to us. Question is, draw a triangle XYZ such that XY equals to 11 cm, YZ equals to 7 cm and XZ equals to 6 cm. Students, before constructing any building, the structure of the building is first drawn on the paper. It becomes easier to construct the building from this drawing. In a similar way, a rough sketch of a geometrical construction makes it easier to draw the required figure. So let's first draw rough sketch of the triangle XYZ. Since XY is longest, let's take it as the base of the triangle. So XY equals to 11 cm, XZ equals to 6 cm and YZ equals to 7 cm. So this is our rough sketch. Now let's construct this triangle. In step 1, let's draw a line segment XY equals to 11 cm with the help of a ruler. And also mention its length as 11 cm. Now look at this rough sketch. We have to draw XZ of length 6 cm. So from point X, Z is at the distance of 6 cm. So students, in step 2, open the compass to 6 cm and with X as center, draw an arc of radius 6 cm as shown here. Now again take a look at the rough sketch. We have to draw ZY of length 7 cm. So it means from point Y, Z is at the distance of 7 cm. So students, in step 3, open the compass to 7 cm and with Y as center, draw an arc which intersect the previous arc at point Z. Now in the last step, we will join XZ and YZ to get the required triangle XYZ. We will also mark the measurements of XZ and ZY as 6 cm and 7 cm respectively. So students, this is how we construct a triangle when lengths of its three sides are given to us. Students, we have a video on proof of area of circle using interesting maths art integrated activity. Do watch this video. The link to this video is below in the description box. Now the next construction is to construct a triangle when we are given with two sides and the angle included by these two sides. So question is, draw triangle PQR such that QR equals to 5.5 centimeter, angle Q equals to 60 degree and PQ equals to 3 centimeter. So to visualize the construction of this triangle, let's first draw its rough sketch. So we will take QR as the base of this triangle, which is 5.5 centimeter. Angle Q is given as 60 degree and PQ is given as 3 centimeter. So this is the rough sketch. Now let's see how to construct this triangle step by step. In step 1, draw the line QR, which is equals to 5.5 centimeter by using a ruler. Do mark the measurement of this line as 5.5 centimeter. Now look at the rough sketch. We have to draw angle Q equals to 60 degree. So in step 2, take the protector and place it on point Q. Then at Q, we will draw QX, which makes an angle of 60 degree with QR. Now mark the measurement of this angle as 60 degree. Now again take a look at the rough sketch. We have to draw PQ of length 3 centimeter. So in step 3, open the compass to 3 centimeter and with Q as center, draw an arc which cuts QX at point P. Then label the line segment QP equals to 3 centimeter. In the last step, join PR. So this triangle PQR is the required triangle. So this is how we construct a triangle when the lengths of two sides and the measure of the angle between them are given to us. Now the third construction is to construct a triangle given two angles and the included side. So the question is, construct a triangle XYZ given that XY equals to 6 centimeter, angle ZXY equals to 30 degree and angle XYZ equals to 100 degree. So to visualize the construction of triangle XYZ, let's first draw its rough sketch. We are given with XY as 6 centimeter, angle X equals to 30 degree and angle Y equals to 100 degree. So this is the rough sketch of triangle XYZ. Now let's construct it step by step. In step 1, draw a line segment XY equals to 6 centimeter by using a ruler. Do mention the length of this line segment as 6 centimeter. Now students, look at the rough sketch. We have to draw angle X equals to 30 degree. So in step 2, put the protector at point X and then draw XA making an angle of 30 degree with XY. Then mark the angle as 30 degree. If you are enjoying watching videos on our channel, then do like, share and comment on our videos. Also, do not forget to subscribe to our channel Learning Notebook. Take a look at the rough sketch. This time we have to draw angle Y equals to 100 degree. So in step 3, place the protector at Y and then draw YB making an angle of 100 degree with XY. So ray XA and ray YB meet at some point. Let's name that intersecting point as Z and do mark the measurement of angle Y as 100 degree. So triangle XYZ is the required triangle. So students, this is how we construct a triangle when the measures of two of its angles and the length of the side included between them is given to us. To learn types of triangles on the basis of sides and angles through a maths art integrated activity, do watch our separate video. The link to this video is below in the description box. Now let's move to construction number 4. To construct a right angle triangle given the hypotenuse and one side. So question is, draw triangle LMN such that angle LMN equals to 90 degree, hypotenuse equals to 10 centimeter and MN equals to 8 centimeter. To visualize the construction of triangle LMN, let's first draw a rough sketch where angle M equals to 90 degree and the side opposite to it will be the hypotenuse. So LN equals to 10 centimeter and MN equals to 8 centimeter. Now let's do the construction of this triangle. So in step 1, we will draw a line MN equals to 8 centimeter with the help of a ruler. Also mention the length of this line as 8 centimeter. In step 2, let's draw angle M equals to 90 degree. For this, students, you can draw it with the help of a protractor, or here I am showing you to draw an angle of 90 degree with the help of a compass. For detailed steps on how to construct a perpendicular using compass, you can refer to my separate video. So here we have drawn MX perpendicular to MN. Don't forget to mention the angle as 90 degree. Now take a look at the rough sketch. We have to draw the third side, that is hypotenuse, which is equals to 10 centimeter. So in step 3, let's open the compass to 10 centimeter and then with N as center, draw an arc which cuts MX at point L. So in last step, join LN and mark the length of the hypotenuse as 10 centimeter. So triangle LMN is the required right angle triangle. So this is how we do construction of a right angle triangle when the length of one side and its hypotenuse are given to us. To learn addition and subtraction of integers through art integrated activity, do refer to our separate video. The link to this video is below in the description box. Now, our next topic is congruence of segments. If given line segments are equal in length, they are congruent. To understand this, take a rectangular paper and fold it as shown here. You will find that its opposite sides coincide exactly. This is an example of congruence of line segments. Now, take a look at these two line segments AB and CD. They are not of equal length. Therefore, they are not congruent line segments. Now students, take a look at these two line segments, AB and PQ. Let's trace line segment AB and place it over PQ. We find that points A and B matches exactly with points P and Q. So it means these are congruent line segments. We will say line segment AB is congruent to line segment PQ, and we write it as shown here. Or we can write PQ is congruent to AB. So from this example, we have learned if line segment AB is congruent to line segment PQ, it means that line segment PQ is congruent to line segment AB. Now, another property of congruence of segments is if line segment AB is congruent to line segment PQ and line segment PQ is congruent to third line segment MN, then it means line segment AB is also congruent to line segment MN. Now let's do an exercise based on congruent line segments. From the shape shown below, write the names of the pairs of congruent line segments. We are given segment AB is congruent to segment DC and segment AE is congruent to segment BH. So segment EF is congruent to segment HG and segment DF is congruent to segment CG. Now, I will tell you all the congruent line segments here. Segment EF is congruent to segment AD, which is congruent to segment BC, which is congruent to segment HG. Then, segment DF is congruent to segment CG, congruent to segment AE, congruent to segment BH. And segment AB congruent to segment DC, congruent to segment EH, congruent to segment FG. Students, to verify Pythagoras theorem using a Maths Art integrated activity, do refer to our separate video. The link to this video is below in the description box. Now, let's move to next topic, congruence of angles. Two angles with equal measures are congruent to each other. Like here, angle LMN is congruent to angle XYZ because both the angles measure 40 degrees. Students, we write congruence of angles as shown here. In other words, if we place angle LMN over angle XYZ, they coincide. So do note that congruence of angles does not depend on their length of arms. It depends only on the measure of the angles. So the first property of congruence of angles is if angle LMN is congruent to angle XYZ, then angle XYZ is also congruent to angle LMN. The second property of congruence of angles is if angle LMN is congruent to angle ABC and angle ABC is congruent to angle XYZ, then angle LMN is congruent to angle XYZ. To verify sum of angles of a triangle as 180 degree using Maths Art Integrated Activity, do refer to a separate video. The link to this video is below in the description box. Now, our last topic is congruence of circles. Circles of equal radii are congruent circles. Like here are the circles of different radius. So if we place one circle over another, then only circle A will coincide exactly with circle C. This means these two circles are congruent circles because they both have radius of 1 centimeter. So students, remember that circles of equal radii are congruent circles. So students, in this video, we learnt about angle bisectors, perpendicular bisectors, property of angle bisector, property of perpendicular bisectors, and we also learned how to do constructions of triangles and congruence of segments, angles and circles. Thanks for watching. See you in the next video. Bye-bye.